Hey everyone, Mr. Skelton here. We are back at it to the start of Unit 10, and the first lesson we're going to talk about today is direct variation. Direct variation, fancy word for something that you actually have some familiarity with. So what we want to do by the end of the day is to be able to recognize and write and evaluate some direct variation equations. So let's jump right into it. Direct variation. Okay, what is it? Well, direct variation, real basic, is by definition, it's two variables that vary directly. Now, you're probably wondering, well, that doesn't really help me out. Okay, basically, what is happening is this: as one variable increases, the other increases. There's a direct variation, meaning there's a direct influence on the other variable. This is the form at which we use direct variation right here, y equals kx. Now in the very beginning I said you've already done this before, and you really have. Direct variation is really no different than this, y equals mx plus b. The only difference between y equals mx plus b and y equals kx is that there is no b value with direct variation, and instead of m, right, we use k. And k is called the scalar, or the constant of variation. You'll see this a lot, constant of variation for the k value, all right? And that's the number that's going to remain constant over time. So here's a perfect example, right? You're making $7 an hour. If you were to go and make this t-chart, as your hours increase, your x values, if x is hours, as your x's increase, so if I plug in a 1, I would get 7. If I plug in a 2, I would get 14. Okay? As I multiply 1 by 2, 7 gets multiplied by 2. So the scales, it has the same scales when you vary directly. It's the same exact thing. Okay? Some people think you can divide, or not think, it's true. When you divide the y by x, you get your constant of variation. Okay? So you'll see y equals kx, but here's the other equation you're going to see quite often when we do this, is if you take the y equals kx, which is what we use for direct variation, and a lot of times they're going to ask you to solve for k, or find the k value, so you will divide by x. And so a lot of times when you're talking about direct variation, you will see this. And basically what this is y divided by x gives you k. That should make sense. Look, 7, your y value, divided by 1, your x value, 7 divided by 1 is 7. 14 divided by 2 is 7. That keeps giving you your 7, which is your k value here. Okay? In terms of a literal translation, when I know I'm kind of all over the place here, I'm going to kind of find some space. You would read this out loud as y varies directly with x. That's how you read this. Y varies directly with x. You don't say anything about the k value when you would read this. This is direct variation. Okay? So it's real basic. The other thing that you need to know, or that you'll find out real quick, since there's no b value, right, since it's the same thing as y equals mx plus b, if you were to graph this on your xy coordinate plane, it's always going to start at 0, 0. Think about it. If you plug in a 0 for x, what's going to happen to y? You're going to get a 0. Since there will never be a b value, it's always going to start at 0, 0, and then you just apply your points, right? 1 and then 7, 2 and then 14, and it's going to be linear. So direct variation is always going to be linear in terms of the type of function that it's going to be when you graph it. Okay? So got a lot of things going on here, but let's try some examples and apply this concept of direct variation. So there's a couple different ways we can do this. So here's an example here where you're given a table and you need to come up with an equation and then just draw a rough sketch. All right, so we're thinking y equals k times x as our equation, or a lot of students will think of this, k equals y over x, to find the constant of variation. So when you look at this, you have x's and y's. What are we missing? We're missing our k. So that's what we have to find in order to write the equation. So what do? We would just divide. just like we did before. If we want to find our k value, we would use this and go y divided by x, y divided by x, y divided by x. If you put these all in your calculator, obviously 3.15 divided by 1 is 3.5, 7 divided by 2, 3.5, 10.5 divided by 3 is 3.5. So what's our k value? Our k value is 3.5. So our equation then would be y equals 3.5x. So every value of x will get multiplied by 3.5. Again, if you were to graph this, start at 0, 0, because if you plugged in a 0 and a 0, and then it's 1 and 3.5, right? And then you get the idea, and we're just going to continue to graph this. Second one here, again, we would take 8.4 and divide it by 4. Got 2.1. Maybe just try the next one just to make sure, double check. Divided by 6, 2.1. So our k value is 2.1. So our equation is y equals 2.1 times x. Again, if you were to graph this, you can graph 0, 0, and then 4 and 8.4. I'm just estimating for sake of time. You know how to graph already. You're going to have a graph, something that looks like that. All right. The ones on the bottom, again, are graphing. Honestly, I'm not going to do these because you should know how to graph something like this, very basic. The only one I want to point out to you is 2 and 3. Call this number 1, number 2, number 3, just in case some students get a little confused in how to rewrite this. So this is the same thing as 1/4 x, okay? So if you do rise over run, if you were to graph this 0, 0, and then up 1/4, you could think of it like that, or you could make your t-chart and go from there. But it's basically, think of it as slope, up 1/4, 3, 4, boom, good. Now, this number 3 I wanted to point out because, again, you can rewrite it like this. It's negative, right? So we're at 0, 0, okay? And then basically we're down 2/3, okay? And you may be thinking, well, you said at the very beginning, direct variation is as one thing increases, the other variable increases or goes up. In all examples that we've done, you can see if I put my x and y, as my x is increasing, oops, get on the paper here, as my x is increasing, you can see my y is also increasing. Same thing with these up here. As x increases, my y is getting bigger. X increases, my y values are getting bigger. Well, what happens when it's negative? Well, it's still happening. As your x value is increasing, your negatives are getting larger. You're getting bigger negative numbers. So the whole idea of as one increases, the other increases still holds true in this specific example with the negative, because as your x's are getting bigger, your negative numbers will also continue to get bigger. Okay? Flip it over on the back. So this is just a recap kind of what direct variation graphs all have in common. They all go through the origin. That is true because, again, it's y equals k times x. There is no b value, so if your x is equal to 0, that means y has to be 0. So that's why it always is going to go through the origin. And they all have a slope, which is the k value. Again, we talked about that already. So those are the two things in terms of graphing that will hold true forever. Some more challenging questions here. I actually want you to try this one on your own. Again, I'll call this one number 1, and I'll call this one number 2. I want you to give it a shot and just see what you can do, and then hit pause, try it, and then hit play and see what you came up with. All right, so it says a direct variation graph goes through the point, should be graph in here, direct variation graph goes through the point of -4 and 34. Write the equations and then find the y value if x is equal to 7. So what they're asking us to do is come up with the equation of a line that goes through this point, all right? So how could we do that, right? Well, let's think about it. If we go kind of backwards from what we did before, if we make a point, -4 and 34, and go back to the first or second slides where we had a t-chart like these, what did we do? We needed to come up with the equation. Well, how did we do that? We looked at our t-chart and we used, as we manipulated the direct variation equation into solving it for k, we were able to understand that if you take the y value and divide it by the x value, you get your k value for direct variation, right? We went 8.4 divided by 4, 12.6, and we got our k value to be 2.1. Well, that's exactly what you're going to apply here. take this point, make it into a t-chart. Let's find our k value. So how do we do that? We know our k value is found by taking our y value and dividing it by our x value. And you get negative 8.5. So we get y equals negative 8.5x. This is the answer. Write the equation. Should be write the equation. Write the equation. Check. Did it. And then find y if x is 7. So all that means is you're plugging in the number 7 in for x. So you just times that by 7, and y would be negative 59.5. That would be our answer for y when x is 7. Okay? Same thing on the other side. You're finding the equation. So I'm going to have x is 2 and then 13.5. So I got to be thinking in my head, okay, what is my k value? 13.5 divided by 2. Okay, that's going to give you 6.75. So our equation is y equals 6.75 times x. That is our equation. And then we're going to find y when x is 11. So 6.75 times 11 gives you 74.25. 74.25. Okay? And I believe that's all I have for you on direct variation. So again, pretty basic concept because you are mostly familiar with this due to your knowledge of slope and graphing y equals mx plus b. But again, it's direct variation in terms of how you can explain it is when one variable varies directly with another, where you have that constant scale. Is if you multiply your x's by 2, then your y's are being multiplied by 2. It's constant. It's that constant ratio over and over. That's direct variation. Okay? Look forward to answering your questions in class. Take care.